Good morning, good afternoon, good evening, depending on where you are joining us from. Welcome to Simplilearn. We are honored to have you join us today for How Recommendation System Works on Amazon and Netflix with your host, Simon Tavasoli. My name is Richard, and after this intro, I'll be mostly in the background helping Simon so that everything runs smooth. How recommendation systems work on Amazon and Netflix. They certainly got me. I know the headset I'm working, when I went on there and purchased it, I actually bought 2 of them. I'm very happy about it, but they got twice the business. If you do not know Simon, Simon is a self-motivated, result-oriented, and high-achieving professional with years of hands-on and leadership experience developing award-winning business intelligence, performance measurement, and analytics solutions. 10+ years of experience teaching certificate courses to statistics and BI tools, specializing in e-learning. Simon has a master's in biostatistics from the University of Western Ontario, along with certifications in everything data and big data analytics. Simon is passionate about teaching data science and has a number of journal publications in preventive medicine analytics. For those who aren't familiar with this form of webinar, I want to introduce you to your dashboard. If everyone could locate the dashboard and then locate the question module. If it has auto collapse, click on the red arrow and then find the question part on there, and go ahead and message hello. Just say hi to Simon. Let him know you're excited to be here. It also lets us know that our sound system is working. And I see we have Alejandro already said hi earlier. Depashis, great to have you. Thank you for being here. Samvav, Sagar, we have a lot of people. Kumar, and I apologize right off the bat if I get your name mispronounced. I have a lot of learning to go to get the names right. This question module is your best friend. As Simon's going through the presentation, go ahead and type your questions in here because we do have a lot of people on. We'll save those questions for the last 15 minutes and we'll do a question and answer period at the last 15 minutes of the session and get to as many of those as we can. If you hear something awesome, brilliant, interesting, insightful, and you want to share it in your social channels, whatever your social channels are, Facebook, LinkedIn, tweet, you can use the hashtag SLWebinars. That way people can find it and you'll make them wish they were here. Go ahead, sit back and relax, have a cup of coffee, tea, or if it's evening where you're at, maybe a glass of wine and enjoy. You didn't come here to listen to me. It's an honor for me to hand this over to Simon for How Recommendation System Works on Amazon and Netflix. Thank you and happy learning. We look forward to seeing you in our classrooms. Thank you, Simon, for being here with us today.
Thanks, Richard. I really appreciate your kind words and great introduction. I hope everyone is good. Sorry about a couple of minutes of delay because of technical issue that we had, but I tried to make that up. So hopefully this webinar could be helpful and would be helpful for you guys in terms of bringing information that you learn in data science class and see case studies. So without further ado, let's start the session. As Richard mentioned, my name is Simon. I have years of experience working in business analytics and teaching data science, predictive analytics, and statistics. And my education was in biostatistics from University of Western Ontario. Objective of this webinar is to learn how to leverage predictive analytics and big data to recommendation system to enhance customers' experience and boost sales. We will first learn a little bit about predictive analytics and recommendation systems. So hopefully you would have a general idea of what recommendation systems are. Then we will go through a couple of case studies at Amazon and Netflix, which are pioneer and leading organization in terms of implementing recommendation system into their business. And then quickly we will review lessons learned from these 2 case studies. Recommendation system. Let's go through some definitions. So recommendation system is an extensive class of web applications that involve predicting user responses to options. So there is this prediction component into it, and also it would provide responses or options that would match that prediction. Recommendation systems help users discover content based on their unique needs and preferences. So it's all about customization and making it tailored to a person's needs and preferences. For example, in terms of an article in an online newspaper, you may be interested in seeing your local news first. A recommendation system would enable that online newspaper to provide local news to you first. So once you go to their homepage, you would be able to see, if you're interested, you will see your local news first. Or if you, wouldn't it be great if you're searching for cars and for some reason you search online and then recommendation system pick that up, and then whenever you go to sites, instead of advertisement for I don't know, shampoo, you will see advertisement for economy car. That is a sort of advertisement that is customized to your needs and it's relevant to your needs. Or in terms of offering customers things that they might like to buy. Let's say if you're interested in buying electronic products, wouldn't it be nice if you go to Amazon, then instead of searching, browsing, and spending time to get to that electronic product catalog, you would see it right up on front page. So this is what recommendation systems would do. A recommender system, a recommendation system, or engine, these are terms that are used interchangeably, learns from a customer. So this is a very important component, and recommends. So based on that learning, it would predict needs and it would categorize, classify a customer, and recommends products or information that he or she will find most valuable. In e-stores, places like Amazon, e-commerce, we will see that recommendation systems, for example, recommend products in terms of product discovery, in terms of loyalty programs, in terms of email campaigns, bills and mailers, and etc. So a lot of use cases that recommendation systems can help different things. Recommender system is what businesses need in many, many ways. And some studies by eMarketer and research companies at some US firm research companies have found that it can bring up to 30% additional revenue to businesses. And that's why business community really recognize that. 78% of business community think that analytic capabilities to understand customer behavior is important, or 78% think that developing content and experience across the entire customer journey is very important. And 3/4 of the business community think that delivering relevant, personalized customer experiences is important. So huge demand, and a lot of growing demand as well. One of the places that recommendation systems are useful is in marketing and advertisement. It enables marketers to prioritize their spend in terms of what to provide customers with, and enable them to understand how consumers behave. It's a huge industry. So for those who know recommendation systems, lot of opportunities, lot of job opportunities. It's a $260 billion by 22 industry. So as you can imagine, this internet advertisement is a huge, huge industry, and recommendation system is an important part of it. And 94% of companies agree that personalization is critical to current and future success. So just imagine a 260 billion industry would need people that would develop them recommendation systems. Just look at this figure below. 27% of Americans think that retailers don't recognize them on different devices. 45% think that digital ads that promote products that they purchase not what they looking to buy next. And really big figures, like 49% of people said that digital ads that are irrelevant to what I'm interested in buying. So if advertisement industry and marketing industry could reduce these bad values, just imagine that how would it be and how successful they would be. So huge demand in marketing and advertising. Also in different sectors like e-commerce, Amazon is an example that will go through, video on demand, Netflix, and many other video on demand industry that use recommendation system to match customers to movies based on their tastes. And social media, customers can view what people with similar tastes viewed, and internet music stations that similar to video on demand, they can match people with their music that they like. Recommendation systems are a type of filter to narrow down a list of available options. So if you could really simplify that, recommendation system is a filter that sits in between items and people, and it would filter items based on user profile. So it's a type of filtering, if you could simplify that. And if you're wondering about what's the difference between a search engine and a recommendation, is that recommendation is a vice versa of searching. In searching, people goes, for example, to Google and search for items, and then they have to browse and find things. But a recommendation system can do the job, can predict and identify a person's taste and preferences, and then recommend those items to the person. So that's how you can distinguish between searching versus recommending. Three popular methods of recommendations, three types of recommendations. We have collaborative filtering, we have content-based filtering, and we have hybrid of these two. So these are just broad types of recommendations. In collaborative filtering, the first one, it's based on interest of a community of users. So a group of users, let's say a group of people who live in New York, they are 20 to 25 years old, and their preferences are similar in compared to a group of people who are 40 to 45 years old and they live in Mexico City. So that's what we mean by interest of a community of users. Content-based filtering, the second one, is based on similar content. So it's, as its name implies, it's based on items. It's not based on people. And we have some hybrid versions. So I will go through a little bit more in detail about the first two, and I will show you that how Amazon uses a hybrid version of these filtering methods. So collaborative filtering. Collaborative filtering, this method finds a subset of users who have similar tastes and preferences. And how they would do that in terms of methodology would be through clustering, classification, and various data modeling. For those of you guys who have taken data science in R, we have gone through some examples of classifying people and identifying them and grouping them together based on commonalities that they share. Basic assumptions of collaborative filtering is that users with similar interests have common preferences, and sufficiently large number of user preferences are available. Main approaches are either user-based or item-based. So user-based, as this example would show, that for example, Tom and Dick are common in terms of item B. They're both happy on purchasing item B. Item B could be an Apple computer. Item based is, for example, Jane, when she bought item A, a headphone for iPhone, and item D, which is iPhone itself. So she was happy when she bought them both. So that's the difference between user-based and item-based collaborative filtering. Now, user-based collaborative filtering use user item rating matrix, as shown in the table below. It makes user-to-user correlation. For example, in this example, user 3. So users are in rows and items are in columns. User 3 and user A, which is a reference person, have shared interests in terms of item 1, item 3, and item 4. So make user-to-user correlation. Find highly correlated users. Recommend items preferred by those users. So there is a star on top of this page, right top part, and it says Pearson correlation and prediction function. For those of you, again, who are engaged in who enroll in a data science course with R, you know that we go through these Pearson correlation and correlation analysis. We go through examples of how to do that, and you see that how big companies and how recommendation system use those techniques in terms of recommending things. So these are the things that I'm trying to link the everyday world and case use of these methods in recommendation systems to what we learn in data science course. In terms of advantages of this collaborative filtering is that no knowledge about item features needed. So it's all about users. It's about what they prefer. So they don't, for example, if it is Amazon, they don't need to know features of, let's go back to that example of iPhone and earphone or case. Protection case for iPhone. So there is no need for the recommendation system to analyze features of those products. It's just based on people who bought these two products and they're happy. And there are some problems. The problems about this particular filtering is that new users, there is not enough information about new users, right? Because if a person is new to e-commerce site, the site doesn't know anything about that person, so it would be hard. So that's one issue. A new item called the start problem is that when a new item comes and there is no prior evidence in terms of how happy people are in terms of buying that item with another item, that is the problem of cold starting with the item itself. There is another issue with the sparsity problem, and that is that there are many items to be recommended that user rating matrix is sparse, and it's hard to find the users who have rated the same items. So what this means, it means that, for example, in Amazon, we have millions and millions of products that are available, and for some items, because it's so huge, some items are not captured properly because it's like people have different preferences, and sometimes you cannot find enough number of people who were happy about a range of items. And we have popularity bias, and that's is that these filtering tend to recommend only popular items. So for example, if a new iPhone is on the market and it's very popular, that would come up a lot in this correlation analysis behind the scene, and that's why, as a bias, recommendation engine tends to offer that a lot. So these are pros and cons of these type of filtering. Now, just a reminder that we are still in collaborative filtering, and this is item-based collaborative filtering. So if we go back user-based. So we are still on collaborative filtering. We had user-based and we had item-based. Now this is item-based. So this is user-to-user item rating metrics. Make item-to-item correlation. Again, for those of you who have taken or will be taking data science, you will see these what we mean by correlation. We will do a lot of this correlation analysis in that course. It's based on finding items that are highly correlated. So, for example, in terms of user 1, you will see that user 1 bought item 4, item 3, and user 1 bought item 4 and item 5, and this is the same as user 3 and user 4. So recommendation system based on this pattern of choosing would know that similar users would tend to buy item 4 and item 5 together. That's why, for example, if item 4 is I don't know, a Microsoft computer, and item 5 is a protection case for that computer or whatever, then based on similarity of these users, recommendation system would recommend that particular item. There are some pros and cons, some advantages and disadvantages about this item-based collaborative filtering. Advantages would be no knowledge about item feature needed, similar to the previous one, better scalability because correlations are between limited number of items instead of very large number of users, and reducing the sparsity problem, new user cold start problem, again that would be a problem, and new item cold start problem. And these are the issues that Amazon and eBay could have. That's why they're using a number of different filtering approaches. Now, the second type of filtering is content-based filtering. So the previous one is collaborative filtering. Just a reminder, this is content-based filtering. This is based on the item. It's not about person. So this type of filtering would ignore people. It would just focus on items. There are two approaches. Either recommend items similar to those a user has liked, browsed, or purchased in the past, or recommendations are based on the content of items rather than on other users' opinion. So an example is here. Then in the figure, you see that if a person had some purchases in the past, a person is really a movie fan and purchased a lot of movies. So recommendation system would go and search the person's past history, and we'll see that there is a correlation between movies that this person bought. And these are sci-fi movies, right? So based on that, and this person could have bought some drama movies as well, but recommendation system can, through correlation analysis, can see that there is a correlation among sci-fi movies. So that's why the recommendation for this person would be another sci-fi movie. So it's about items. In terms of user profile, and in terms of how this content-based filtering is that it creates user profile to describe the type of items that user prefer. So what we see in that gray box is a user profile, right? It would show that this user bought n number of movies, and this would be the user profile. And recommendation is based on the basis of recommendation could also be based on the keywords that the person used, right? So this gray box says past purchases. It could be past searches, right? The person could have searched a lot about sci-fi movies or action movies or particular products. So that's why this content-based filtering is based on these either history of purchases or searches. This table is just to show you that there is no one tailored. There's no one solution. It's not there. It's not like one solution would fit for all, right? So companies would use a number of different approaches. For example, in the red box, it will show you that how Amazon used. In Amazon, we have customers who bought things. So the recommendation interface is based on similar items. Recommendation technology is item-to-item correlation based on purchase data. Or they have email campaigns. I and Amazon.com delivery. These are emails. Again, it's based on attributes of products or people. Book matches or customer comments. So companies use many different. Or the second example, you see that CD Now use two different ones. It's Album Advisor and My CD Now, which is based on recommendation is based on similar items or top or popular items on the website. So the take-home message is that there is no single solution. Companies tend to use many different filtering approaches, and recommendation engines would take into account scenarios for different type of customers and different type of situations. In terms of content-based filtering, there are some advantages, and again, this content-based filtering is what is analyzed based on items, based on products. So no need for data on other users, so no cold start, and able to recommend users with unique taste. So first of all, because it's based on items, based on products, so a person would come to the site, and the website already knows who that person is, and so no cold start in there. And it's based on that person only. So I could be a very movie lover person and interested into certain movies and have a unique taste. So recommendation system would know that and would recommend things that I like. It's not based on an average person or all other people who live in my area. So it's based on my unique taste. And another advantage of this content-based filtering is that it able to recommend new and unpopular items. So again, it's not based on behavior of everyone else. It's based on me only. Limitations is that data should be in a structured format. In a structured format, it means that user profile that I just mentioned previously. And another limitation is that it's unable to use quality judgment from other users. So, for example, if I love Apple products, so recommendation system would keep recommending things related to Apple products, or maybe let's use Samsung, right? Let's say I love Samsung, and recommendation system would recommend Samsung Note 7 to me, right? But because it would take into account only me, then it wouldn't be able to take into account that Samsung Note 7 would get fired, and now so many people have issues with that, right? So it would recommend that product to me despite the fact that that product may not be a good one. So that's what we mean by it's unable to use quality judgment. Okay, so we got a little bit of high-level understanding of what recommendation system is, like methods in terms of filtering based on people's taste or based on items, and we know that companies use many different approaches. Let's go through case study, an example of how recommendation system is used in real world in a big company like Amazon or in other e-commerce companies. Recommender systems are changing from novelties used by a few e-commerce sites like Amazon to serious business tools that are reshaping the world of e-commerce. So they are not a luxury thing anymore. They are a needed, a must thing for e-commerce companies. E-commerce. E-commerce is a huge sector of industry. Worldwide retail e-commerce sales will reach $1.9 trillion this year. So $1.9 trillion. Just imagine how big this industry is. Double-digit growth will continue through 2020 when sales will top 4 trillion. So not only it is a big industry now, but it is going to be more than doubled by 2020. And in the figure below, you'll see that some examples that in Black Friday or Cyber Monday sales comparing 2013, it was 1.2 billion in 2013. It went up to 1.5 and then 1.2, 1.7. And not only in US, in China, it went up from 5.7 billion in 2013 to 14.3 billion in 2015. So e-commerce is huge. It's not only in certain countries, certain markets, it's all over the world. So people who would be able to work in this area would have a lot of opportunities, not only in, let's say, North America or Europe or Asia, but everywhere. And it is a growing industry. Now, let's use Amazon as an example of this sector. Amazon is a gold standard of e-commerce. It's a pioneer company in using recommendation system. In 2015, Amazon surpassed Walmart as the most valuable retailer in the United States. It is the fourth most valuable public company. Its revenue is $107 billion. It was in 2015. And it employs almost 70,000 people. And these 270,000 people, a lot of them are IT. It is all about online sell, right? And these are people who have knowledge of data science, IT, etc. So huge opportunity in terms of working in Amazon. Recommendation systems or engines can offer recommendations about collective preferences in Amazon, on Amazon website. So that's the first type of ways that recommendation system in Amazon works, and that's based on collective preferences. So let's say if this is the first time that you go to Amazon's website, it would look like this. They look like the figure, and you will see that there are some recommendations, and this is based on popular items that are satisfied some pre-specified criteria, like number of items viewed in my local area. For example, if I live in New York, in Manhattan, and people in my area at certain time of year tend to look for certain items that would be picked up by Amazon. And if Amazon doesn't know anything about me on the first page, when I go there, I will see things that are based on what people are searching in my area, or time on item view. Sometimes people may by mistake click on something and then quickly go to another item. So Amazon's recommendation system would also take into account time and number of purchase times. So these are also additional indicators to show that these preferences at my local level. It could be as small as a street level, or it could be as small as people living in my building, or it could be about people in my country. So this is when Amazon doesn't know anything about you guys. When you go there, based on collective preferences, it will recommend some stuff that would be likely relevant to you guys. In terms of non-personalized recommendations, and sorry it was this, the word is cut. It's because sometimes I use, I apologize guys, sometimes I use Windows to make my slides, but by default I use Mac, so that's why you see that these words are cut on the side. It is a little bit distracting, I apologize. And by cutting out, it means that that N at the end of recommendation is not properly adjusted. I apologize for that one. Going back to topic, non-personalized recommendation. So non-personalized is about this. It's not personalized, it's about collective preferences. So what we learned here, it was that based on my local level searches and patterns that Amazon would pick up, it would recommend something. But as person begins to browse a few pages, the engine determines person's preferences and leverages this information to offer tailored recommendations. So this is the online analysis part of this recommendation system, that as a person goes page by page and views things, these recommendation system would pick up information. Source of items of known interest with respect to users. As you can see on this top side, there is a search, there is this account, there are campaigns, wish lists, cards. And from all these sources and navigation, Amazon would know that what you like and what your preferences are. If user rate something or choose that items as a favorite items. So these are all sorts of different ways that Amazon would pick up information from you guys or collect information. And this is the way that the data acquisition happens in Amazon. And in terms of once Amazon has enough information about you guys, it would go to personalized recommendation. Now, recommendation engine offers recommendations based on customers' previous behavior or sort of purchases and browsing history. This is called content-based filtering, right? Going back to those types of filtering. So this is the point that Amazon knows about me, and based on my previous browsing history, it will recommend things that are relevant to me. Personalized recommendations, you have seen that the customers who bought futures is found on the information page for each items. The first one is frequently bought together. This is things like association rule mining a priori. For those who have taken data science with art, they know that we did a little bit of example with this particular algorithm, and this is something that we learn in that data science batch. Another thing is this is a sort of a content-based collaborative filtering. Recommendation items frequently purchased along with this item. Another one is what other items do customers buy after viewing this item. This is more about correlation or conditional dependence. Again, we learn these things in data science in R. This is a user-based collaborative filtering. It recommends items frequently purchased by customers to purchase the same items. There are also additional recommendations on the shopping cart page. So as you can see, on each page there are recommendations. And this is a high-level sort of recommendation engine that is in Amazon. There are items of known interest and those popular items. They would fit into a matching processor, and this matching processor would pick up feed into popular items. Popular items are items that they have satisfied some pretty specific popular criteria, like page view, time that people spend on that, bounce rate, exit rate. Then from that matching, then that similar item list is generated. And this is associated a commonality index to indicate the relatedness of items. And from there, those similar item lists are weighted. And by weighting, by relative importance. For example, this similar item list could be, if I love Samsung, it would be Samsung like Note, Samsung, I don't know, AirPod, etc. And then it would go through a weighting process, and based on relevance. For example, if I bought a Samsung Note previously, and Amazon knows that, then this weighting processor would know that I bought Note 7. So a case for Samsung Note 7 would be of higher weight than a case for, I don't know, iPhone. Or it could be based on my ratings of previous items. For example, if I want to buy a computer and this popular item list has Apple, has Windows, whatever, the different HP, whatever different items, this weighting processor would know that my rating previously was more better in terms of Apple products, and it would recommend Apple products. So algorithm is very complex, and it will go through a step by step to make it more and more customized to person. So this was about a high-level understanding of what things, how recommendation system works in Amazon. Let's go quickly through a second case study, which is Netflix. This is a video on demand company. It helps members find content to watch and enjoy to maximize member satisfaction and retention. A huge company, $6.78 billion in 2015, 86 million members, 50 plus countries, so many devices, and so many million hours a day. And as you can see in the figure, at peak hour at 10 p.m., the share of that in North America, the web traffic for Netflix, it's in red, it's almost the same as all other streaming videos. And just look at that gray area, web browsing, and compare it to Netflix. So the share of web traffic is huge for Netflix. Netflix is all about homepage. Homepage is what Netflix recommends. Rows are thematically coherent. It means it is by movie genre, action, sci-fi, etc., and by ranking. And what we mean by ranking, it means that top row is the best guess. For example, the first movie that you see is what, and because Netflix collects information on everybody who watches movies in a household, so the first thing is the best one that would fit everybody's demand and need. So all family members may like the first one. Father may watch a lot of movies and would be interested in the second one. Daughter and father may like the third one, or mother likes the fourth one, etc. So this is how data that is captured through implicit ways is used in terms of recommendation. And recommendations are generated based on users' recent plays, ratings, and interactions, or taste. Like I may watch a lot of action movies, and that would be my taste, or a hybrid, a combination of both. I may love action movies, but recently I've seen some nice drama, so the hybrid version would take into account both scenarios. You don't need to read all of these. This is just to show you that Netflix has a lot of data, ratings, popularity of movies, plays, people's interest in terms of actors, presentations. They have information about social media. Like, for example, they know that I have 200 friends that most of them like action movies. So all of this data, which is the so-called big data, is captured by Netflix. So data from all sources. So when we say big data, and this is the so-called big data, this is an example to show you that how these capture data from so many different places would create these huge big data situations. And this is just to show you that Netflix uses a number of open source softwares at the back end, things from Apache to Hadoop to MySQL to Hive. This is a sort of technology stack that is being used in Netflix. For example, if you're interested in terms of big data, I know that big data with Hadoop and Apache are being offered um, at Simplilearn. And for any of you who are interested in any of these technologies, I think there is a batch, there is a course for these in Simplilearn. There are many different computation layers. You see on the top, and data is with big data is saved in Hadoop. It's processed and queries to Hive, and then there are offline storage area, which is the area that it's live or connected to the computer. Then we have nearline layer, computation layer, and online. So this slide is just to show you that there is very, very complex processes involved in this recommendation engine and technology at Netflix in general. So for people who are interested in different parts of the technology, there are different courses to take and different opportunities are being offered. This is, algorithmically speaking, on the top figure, you see that a simple way to say that how business is in Netflix is that you have thousands of possible movies. But at the end, when you turn on your TV, you will see 10 to 40 rows, and these are the best things for you. How it works in a simplified manner is that it involves predicting personalized rating. Again, I forgot to put the star there, but for those of you who have taken data science with R or will be taking data science with R, we will go through this predicting the practices, regressions. These sort of are a simple way of predicting things. So first there is a prediction involved, then personalization ranking, and at the end this is personalized homepage. So a very simple demonstration of what this business is all about in 3 steps. In terms of algorithms that is being used in Netflix, they have 3 types of main algorithms. There is restrict Boltzmann machines, and this SVD, you don't need to, you can get more information about this algorithm. It's not of the interest of this webinar, but this is just to show you that they use different algorithms. And the second algorithm is actually, if you Google it, you will see that there is a nice story about it, that SVD was built by a team of data scientists in 2009. And there was a prize of $1 million. So it was a sort of competition, and a team of data scientists developed that algorithm for Netflix. Netflix used many different methods, unsupervised methods like clustering algorithms and supervised classification. Again, for the data science students, you know that we go through unsupervised and supervised algorithms and methods like linear regression and logistic regression. So you see that how these methods are used in day-to-day work in big companies like Netflix. And for those of you again enrolled in data science, you know that there is a step-by-step process, and this is from Netflix's side, that how they develop technology. They are a data-driven organization, and they call it consumer data science. So they call this culture a consumer data science. And the main goal of this consumer data science approach is to innovate for members effectively. So they come up with initial hypotheses. So for those of you who know hypothesis testing and data science will learn about hypothesis testing, it's about coming up with an idea that, for example, a certain algorithm would increase number of customers or satisfaction. Then there is this development and independent testing and choosing a sample of customers and testing these hypotheses on them. So these are the things that we learn at data science with R, and you see that how they are being used in Netflix. In terms of what is next, big things that you guys could expect is personalized learning to rank. Context awareness. Context awareness is what time of year it is, what mood I am in, and this is about contextual information. For example, if I am in a trip to India, I might like different movies that if I am sitting in my home in, I don't know, New York or Toronto. More knowledge about cold start, about predicting people if we don't have enough information about it. This is what it means by cold start. These are future direction that data science going, especially at companies like Netflix or Amazon. And social recommendations. These are the four big areas of data science, and there are huge opportunities in terms of growth. So lessons learned: recommendation system enable businesses and clients to find things that are interesting, narrow down a set of choice. It helps people and businesses to recommend things that are of interest to people. Additional and unique personalized services for the customers. Customization is by client and user, and it would enhance trust and customer loyalty. And companies obtain more knowledge about customers and can use them to make them more satisfied and increase their engagement. And it's an effective solution for long tail. And long tail are those products that are at the end and are not that popular. So we are almost toward the end. We started a little bit late, but we have still a few, and I know that I went quick. I wanted to provide you with as much information as possible. This presentation, I believe it will be available on demand. So if I went quick, it just meant to provide you with as much information as you need. So at this point, I guess
Simon, I'm going to go ahead and interrupt you. Excuse me, this is Richard in the back. I said I hide in the back for most of this, which I did. We have a number of questions coming in, but before we start filling the questions, I'm going to take over the screen because we do run a poll. It's always an important part of our setup. So I'm going to take over the screen while we do the Q&A.
Okay.
And while we're doing the Q&A, we have a number of questions coming in. One of the big ones is there a comprehensive learning program offered, specifically in Simplilearn? And I know we have the master's programs. Can you talk a little bit about that? Like what kind of programs they have?
Sure. Exactly. So as I was explaining throughout the presentation, I tried to link that what's going on in real world and in these huge companies with what we learn at in particular data science. And I mentioned about different technologies. For example, I mentioned about different technologies that is being used in Netflix. Now, Simplilearn has a master's program in data science. That in that program, I believe that the data science is part of it. So data science would be foundation. Throughout the presentation, I mentioned about these prediction, about correlation. These are the things that the students will learn in that data science. And on top of that, there are additional batches in that master's program that people will learn about big data. I mentioned about big data, about all those sources of information. So those are given that huge databases, people need to use certain technologies, things like Hadoop or Apache, stuff like that. So as part of that master program, people would also be able to learn about those technologies, about those tools. So master's program in data science is one that could enable students to learn everything that I just explained.
Okay, excellent. And then we do have a couple questions, and you mentioned it a little bit about, and I'll go ahead and fill this one for a second. Uh,
Mhm.
is this recording, is this being recorded, and is this available afterward? The answer is yes. They do record all our sessions back at Simplilearn, and it takes up to 24 hours for them to post it because they have to physically check and make sure something doesn't get messed up. You know, don't want to post an empty file. And then if you go to Simplilearn and you go under the support, just click on the support and request. You can just request it, and they'll send you the link for that for the session today. Just mention today's session, and they'll send you that information. We do have a lot of questions coming in here, so let me see how many we can get through before we'll go a little bit over, because we are at the end of the hour. Um, One of the people asked, what would you suggest if they're not technical? So this is somebody who doesn't want to learn the programming or the Hadoop file system for big data, but they're coming from the management side, project manager who wants to understand the analytics a little bit more so they know what they're talking about when they talk to somebody in their company.
Mhm. So there are many opportunities in terms of non-technical stuff. A project manager may need to know about a little bit of technical, like for example, a data science was R, we go through some technical information, but those technical information are needed for a project manager because a project manager would need to know about estimated time, how much effort is needed, and having at least some technical information could help a project manager in terms of better identifying risk, estimated timelines, and stuff like that. So I encourage a project manager to have, for those who are interested more on business side, to have at least some, I mean, a project manager, a business manager doesn't need to create an algorithm or run correlation analysis, but a project manager or a manager may need to know that in the type of business that they are, they would need certain technologies or certain approaches and estimated time. So having that minimum knowledge is needed. I know that at Simplilearn we have so many project management courses as well. So those are the parts that are business related. So courses that are being offered specifically for business side, I encourage people that are in business side to at least have some technical knowledge. Now, another area that people could get involved is about understanding marketing part of it. So marketing means to understand clients in terms of helping technical people to build models. I mentioned about these models. For example, people live in New York, 20 to 25-year-old versus people live in Paris 40 to 45. So these are the sort of knowledge that are needed in order to build these models, but they don't necessarily come from technical people. So marketing and those sort of approaches are also needed. If a person wants to work in these sort of companies, they certainly need people that would have that sort of knowledge and bringing that sort of skills. But again, they may need some basic technical information as well in terms of opportunities, in terms of what is possible and it's feasible as well. So hopefully I answered it.
Oh, excellent, excellent. No, I thought you answered it quite well. It is a complicated subject because
Yeah,
you certainly can go on to Simplilearn and go under one of the forums and ask for more detail specific to your situation and what industry you're in.
exactly.
If we had time, I'd ask you to ask that question again and fill that in. But we do have a couple more questions I'm hoping we can get to before we hit the end of our period. Um,
Sure.
we have a question that came in. Let's see, where was it? What languages are used for data science? From I'm going to mispronounce this name, Sachin?
Right. So many different languages depending on which area and what companies are a person works. But most popular in data science, in business analytics, um, two of the most popular ones are that are used for analytic purposes are R and SAS. These are languages that are very popular. R is even a little bit more popular because it's free and it's open source software. SAS is very expensive, but some companies use SAS as well. Those who learn R would have a little bit of background, and it would make it easier for them to learn SAS and vice versa. So these are the top two most popular languages in terms of business analytics. And of course, we have languages for big data that are based on the big data. But in terms of typical business analytics and data science, R and SAS are the standards.
Excellent. Let's see. Let's go ahead and do one more question. I got kind of a long one, so it took me a few minutes to put it together from Alejandro. He's asking about in Amazon, when they do the Amazon recommendations and they recommend two different, like gardening, let's see, oops, my thing's flashing around, two different recommendations. Could you please clarify the difference between collaborative item-based filtering, content-based filtering, and how do they get, I don't know, I'm not doing a good job going through this. My apologies. I guess he wants to know is, how do they do recommendations on getting multiple items so they're not related, like toilet paper versus iPhone? That was the example he gave.
Mhm.
How does Amazon deal with that, having multiple, melding all their different recommendations together?
So the difference between the two main types of filtering is that one of them is based on person. For example, if I go to Amazon and buy a bunch of stuff, house cleaning, toilet paper, and stuff like that, throughout time, the first couple of times, yes, I may buy some irrelevant stuff. So that's why Amazon may use item to item filtering approach, may use that. But eventually throughout time there would be a pattern. Like it's not like I always go to Amazon and buy things randomly. I would use Amazon for certain things. So throughout time, Amazon will learn that yes, today I bought an iPhone and a toilet paper, but it was because it was just today that I ran out of, and Walmart, I couldn't go to Walmart and buy that. So I was on Amazon and I bought it. But throughout time, it would learn about that. But meantime, item to item correlation could also help address that. For example, those who bought iPhone are not likely, is not associated with buying toilet paper. Is associated with buying cases, with buying additional things. So if there is enough knowledge about a person to reduce noise, and that toilet paper in data science is called noise, it's irrelevant data. So there are ways to understand how good data is and to exclude noise from data. Now, if Amazon has enough knowledge about my behavior, it would reduce that noise and it would take into account correlated stuff. But if not, then it would go to item correlation, and it would, for example, in two boxes, it would show you one that what other people who bought iPhones bought as well, and another one would be people who bought toilet paper, what else they did buy. So you see, that's why they are using hybrid and many different ways, because in real world it's not as simple as people's behavior would be the same. So there are plan A, B, C, and D's for every scenario, and this is what algorithms come to work.
Excellent. And do you have time, Simon, to hang around for about two or three more questions?
Of course, sure.
Okay, excellent. One of the big questions that comes up a lot that I hear, because it's quite the catchphrase, is AI, artificial intelligence. How does data science relate to AI? Is there a relationship between artificial intelligence and data science?
For sure, AI is all about it's data science is the foundation of that, and it's about learning uh, and learning from behavior, and it is actually a big area that is going to be used in businesses. So they're directly related.
Okay, excellent. And I actually was working with a group earlier that had Spark on the big data Hadoop, and part of it was the
Mhm.
machine learning was part of the AI they were working on. So that was my experience. It's exciting stuff. Um,
Yep.
let's see, let's see if we can get a couple more in there. How does run recommendation engine at scale? So how does this scale up when we're doing the recommendation engine? How do they get that scaled up for this massive amount of data? I mean, Amazon has what,
It's
terabytes
in
and
three steps. In three steps, offline, nearline, and online. In three different steps. It's a huge. I cannot really explain it in one or two, but in that slide that I mentioned about offline, nearline, and online, they that is basically to scale that, and also in terms of technology, they're using many different technologies, like you mentioned about Hadoop, and big data technologies that they have in terms of these large amounts of data. And I know that we have a badge in Simple as part of this master's in data science that would talk about these technical issues.
excellent. Yeah, this stuff's always, I get excited about this stuff. So I love being in the back on these webinars. Let's just sneak a couple more in there because we still have people coming in with questions. Can you explain the difference? Where's the line between data science and statistics, and how do they overlap? Data
They do
science.
overlap a lot. Data science, for a person who wants to work in data science, a person would need to have knowledge of programming, knowledge of technology. So technology is part of it. How to work, for example, with R, SAS, etc. And another part of it is the statistics, is about, for example, when I mentioned about correlation, about building models, about these clustering, classification. These are statistical approaches. It's a requirement, it's a must for a data science person. It's a must to know statistics as well. And that's what the data science with R is about. In big part of that data science with R, we go through statistical approaches and we use software to apply those statistical concepts. They are interdependent.
Excellent. And then one last question. We're going to do just then we're going to wrap it up. Do you have any books you can recommend or references that somebody who wants to gain a little bit more knowledge in data science?
I don't have it right off bat, but if you guys attend any of data science classes, at each class and for each topic, I usually recommend some books, but unfortunately, I was not expecting this question. But if anybody wants that, if you go to Simplilearn community forum, we can be in touch there. I can put some information to some answers to these references. There are a bunch of great books that online resources that people can use. So maybe that's a good way to for us to communicate.
Excellent. Well, thank you, Simon. And it's a good reference. That was for Rajesh, who was asking about that, and I hope I said the name correct. Um, we do have the forum, so if you have more questions or anything like that, you can go to Simplilearn and then go under the community. And there is an open community there. You can ask questions, and then if you are registered, there's also the Simplilearn Simply Talk for those people who are registered students. Thank you very much, Simon, for being here today and taking your time to do this webinar with us.
Thank you so much. I really appreciate everyone's attendance and your questions. And Richard, thanks for your support and everything.
Excellent. I'm going to go ahead and close the session, and I wish everybody happy learing. I had, by the way, Sajin says, thanks, Simon. Yep, thanks
Thank you.
everyone from Alejandro. Alejandro, hope I said that right. Uh, there we go. Everybody have I wish you a wonderful evening, afternoon, or morning. We look forward to seeing you in the classes, and take care and happy learning.